Today's objective is to investigate the interior and exterior angles of polygons. So polygons, let's talk about interior angles again. If we have a polygon, let's say, I don't know, that has 5 sides, our interior angles are going to be the angles that are inside the polygon. So if this is a polygon that has 5 sides, that'd be a pentagon. So we should have 1, 2, 3, 4. We should have 5 interior angles. Let's move on to exterior angles. If we have a polygon, let's say, I don't know, let's go with that pentagon again, 5 sides. The way to find out your exterior angles is by doing this. Start at any vertex. Let's just start there, for example. So start at the vertex, and let's extend the line from there all the way past the polygon. Let's do that again for this vertex. Just past the polygon. Now at this vertex, just past the polygon. And one more. So by drawing those lines, you can see that we have now formed exterior angles. So when I ask you to find me the exterior angles, or when I tell you exterior angles, this is what we're talking about. We're talking about the angles that are formed when you extend one of the sides of the polygon past the polygon. And you might be asking, well, what if we go the other direction? Well, you can, but the thing about exterior angles is that you don't want both sides. So for example, let's say I went this direction. Since I use this vertex, I can't count this angle and this angle. You're only allowed to count one angle. So that's why I said go clockwise, extend the lines clockwise, and make sure that they just pass the polygon. And you're going to be counting all those as your exterior angles. So as you can see, this is a 5-sided polygon, a pentagon, so I should have 1, 2, 3, 4, 5 exterior angles. Let's move on. So this is something that we've done already. This is interior angles, and I want us to go down this list and see if we remember how to calculate all of these. So as we can see with this first one, this has 1, 2, 3, 4 sides. So let's go ahead and write that down. We have a 4-sided polygon. That's called a quadrilateral. And how do I find the sum of the interior angles of a quadrilateral? Well, I thought we already knew that. That was a theorem. Angle 1 plus angle 2 plus angle 3 plus angle 4 is always equal to 360 whenever we have a quadrilateral. Well, what happens if we have, let's see, a 1, 2, 3, 4, 5-sided polygon? Okay, that would be a pentagon. What are the sum of the interior angles of a pentagon? That's when our formula comes into play. We take n minus 2 times 180, and that should give us the sum of our interior angles. So let's go ahead and figure that out. 5 minus 2 times 180, that is equal to 3 times 180, which hopefully you guys have, is 540 degrees. Let me give you a few seconds to try to figure out all this information for me. Well, actually, we're not done. What I wanted to go back and do was this. If you notice, all sides and all angles are the same on this shape. Excuse me, on this polygon. That means this would be a regular polygon. So since it's regular, all sides and all angles are the same. I want the value of just one angle. Well, since I know that there's 5 sides, I'm going to take 540, and I'm divided by the number of sides. So 1, 2, 3, 4, 5, or the number of angles, which is still 5. And if you guys can do that for me, go ahead and tell me what you get. Hopefully we got 108. If you didn't, that's all right. We're going to move on. Let's get the number of sides of this next polygon. Looks like we have 1, 2, 3, 4, 5, 6 sides. That'd be a hexagon. And this also appears to be regular, so I know that all sides and all angles are going to be equal. The sum of the interior angles, I need to use my formula again, n minus 2 times 180. So that's going to be 4 times 180. 4 times 180 should be 720. Now let's get the value of just one angle. Well, since everything's equal, all the angles are equal because it's regular, we're going to take 720 divided by the number of sides, which is 6. Go ahead and divide that for me. I'm hoping you got 120 degrees. And let's do the same thing now. How many sides do we have? 7 sides. Also appears to be regular, so I know everything should be equal. The sides should be equal. All these angles should be equal. 7-sided polygon called a heptagon. The sum of the interior angles, n minus 2 times 180, so 7 sides minus 2 times 180. 5 times 180. Should have 900. If we want the value of just one angle, since they're all equal, we just take 900 degrees, divide it by 7. And if you're guessing, yeah, we should have a decimal because it's not going to go in evenly. So we're going to have to round, we're going to say approximately 128.57 degrees. So don't freak out if not all of them come out perfect. You're going to get some decimals. And the last one, number of sides. 1, 2, 3, 4, 5, 6, 7, 8 sides. We have an octagon. Sum of the interior angles, n minus 2 times 180. Six times 180, what does that give us? 1,080 degrees. And if I just want the value of one angle, we'll take 1080, divide that by 8 sides, and you get 135 degrees. So if we go back up our chart, starting with the first regular polygon, which was our pentagon, 108, 108 degrees. Well, that means that every single one of these angles inside is 108 degrees. For our regular hexagon, each angle inside is 120 degrees. For our regular heptagon, each angle inside was 128.57 degrees. And I'm going to write it out here and just draw an arrow on the inside so you know that's where it goes. For our regular octagon, each inside angle is 135 degrees. Now, I also want you to notice the key word appears regular. Starting with, not the quadrilateral, but starting with the pentagon, all of these polygons were regular. So anytime we had a regular polygon, to find the value of just one angle, we divided by the amount of sides. So if we take the formula for any polygon to find the interior angles, which is n minus 2 times 180, n minus 2 times 180 gives us the sum of the interior angles. Well, if you just want only one, you divide by n. So n minus 2 times 180 divided by n gives you the value of one interior angle. But I hope you've been paying attention. You can only use this formula if your polygon is what? Your polygon must be regular. Let's move on. Examples. It says find the value of an interior angle of a regular octagon. Well, let's use our proofreading skills. Let's see. It says find the value of an interior angle. So we want to find an interior angle. They're telling us that that polygon is regular and it's an octagon. So an octagon has 8 sides. I think I'm going to have to start with my formula n minus 2 times 180. And since they want us to find the value of just an interior angle, that'd just be one interior angle. They don't want us to find all of them, they just want one. And since I see the word regular, I know I can use my n minus 2 times 180 divided by n. Because this formula gives me the value of just one inside angle. And I'm allowed to use this if my polygon is regular. So the only thing you need to ask yourself is, well, what do I substitute for n? Well, how many sides does an octagon have? 8. So it's going to be 8 minus 2 times 180 divided by 8. So go ahead and solve everything in the numerator first. That's going to be 6 times 180. And what is 6 times 180? $1080. So now you can divide 1080 divided by 8 equals 135 degrees. So that means if you had a regular octagon, each inside angle should be 135 degrees. So how would this question change if I gave you a different polygon? Well, all you need to do is make sure you see the word regular, that it just wants one interior angle, and then just look to see what type of polygon they give you to get your number of sides. So how about you try the next one on your own? Well, again, I see it wants me to find the value of an interior angle or an inside angle. I see the keyword regular, and I see decagon. Decagon means 10 sides. So I need my formula. N minus 2 times 180. But since they just want one interior angle, and I have a regular polygon, I get to divide by n. Decagon is 10 sides, so I'm going to be using 10 for n. Let's go ahead and substitute that in. And hopefully you have made it that far. It's just a matter now of checking our answer. So if you haven't made it that far, continue. If you have, let's see what we get for our final answer. which gives you a final answer of 144 degrees. So if you had a regular decagon, that's a 10-sided polygon, each inside angle should be 144 degrees. Moving on. This question's a little bit different, so please make sure you are listening. It says the value of an inside angle, interior angle, of a regular polygon is 120 degrees. The question this time is telling me how many sides does the polygon have? So this one's going backwards. The value of an interior angle of a regular polygon is 120 degrees. They are already telling me what the inside angle is. I still need to use my formula. N minus 2 times 180 divided by n. The reason why I'm writing this down is because they're telling me they want an interior angle, the polygon's regular, so I know I have to use this formula. Except, since they're telling me what the polygon is, or excuse me, what the inside angle is, since it's 120 degrees, I can go ahead and set that equal. So I'll put 120 degrees right here. Now it's just a matter of working backwards and getting all your variables on one side, doing some algebra. Let's go ahead and figure that out. I really don't want a variable down here in the denominator, so I'm going to multiply both sides by n. And what I do to one side, I must do to the other side. These n's will cancel out, and I'll be left with n minus 2, in parentheses, the quantity, times 180 is equal to 220 n. Over here I see some distributive properties, so let's go ahead and distribute. 180 times n, well that's just 180n. 180 times a negative 2, well that's just minus 360. Let's get all our variables on one side. Let's go ahead and subtract 120n since this is a smaller variable. So we're left with 0 is equal to 60n minus 360. Go ahead and add 360 to both sides. Looks like you can already see your next problem. So 60n is equal to 360. Divide both sides by 60. And we get n is equal to, let's divide out those 10s, 36 divided by 6 is equal to 6. So that means n is equal to 6, and if n stands for the number of sides, that means you must have had what type of polygon? 6 sides is a hexagon. Let's try the next one. A regular polygon, again, keyword here regular, has an inside or an inside interior angle of 135 degrees. How many sides does it have? Start off with our formula. N minus 2 times 180 divided by n. And the reason why I'm using this again is because I see the word regular and interior angle. They only want one, and they told us what it's equal to already. So let's set it equal to 135. Let's go ahead and do our algebra. Multiply both sides by n. And let's clean this up. These will go away. So we're left with 135n is equal to n minus 2 times 180. Distribute. So you get 180n minus 360 is equal to 135n. Now, depending on how you like doing your algebra, again, you could have moved the 180 to this side by subtracting 180. I always prefer to get rid of the smaller variable, so I'm just going to subtract 135n. What I do to one side, I do to the other side. So I'll be left with 0 here. Don't forget to leave that 0 there. So 180 minus 135. I'm left with 45n minus 360. So let's keep going. Add 360 to both sides. $45n is equal to 360. Not too much more work to do here. Divide both sides by 45. So n is equal to, I'll give you an opportunity to divide that. You should get 8, or 8 sides. And something with 8 sides is is an octagon. And that's pretty much what we need to do today. Oh wait, we forgot about exterior angles. So here we have an example of a polygon that has, let's see, 1, 2, 3, 4, 5 sides. That means if that has 5 sides,
please report to the guidance office. Lazaro Castillo to the guidance office.
okay, if it has 5 sides, that means it must have 1, 2, 3, 4, 5 exterior angles. Now here's something I probably should have told you earlier, but any polygon, doesn't matter if it's 5-sided, 6-sided, 7-sided, 12-sided, any polygon, the sum of its exterior angles the sum of the exterior angles of any polygon is 360 degrees. So that means that angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus however many angles you have on your outside polygon, on the exterior side, is always going to have to sum up to 360. And that's pretty much it. If your polygon is regular though, so this is a pentagon because it has 5 sides. This is a regular pentagon because all sides are equal. So if you have a regular polygon and you want to figure out the exterior angles, or if you just want to figure out one exterior angle, then all you need to do is take 360 and divide it by n. So let's take a look at some examples. A regular polygon has an exterior angle of 60 degrees. How many sides does it have? Let's take a look at our keywords. The polygon is regular. It has one exterior angle that is 60 degrees. How many sides? Well, since it's regular, I want to use this formula. All polygons, the exterior angles, should add up to 360. But if they give me 1, that means I have to divide it by n. And since they told me what that was equal to, which was 60 degrees, I substitute that in for what the answer should be. Do some algebra. Multiply both sides by n. So 360 is equal to 60n. Divide both sides by 60. 36 divided by 6 just 6. So that means you have a hexagon, or 6-sided polygon. And I think we are done. Time for homework.